Okay, so we're going to look at, I suppose, the next type or last type nearly of this sort of question for finding the equation of a circle, which is finding the equation through 2 points where we're maybe given a line on which the centre lies. And again, we've two ways of looking at this. We can look at it geometrically, and we can look at it algebraically. So we've our two, I suppose, different approaches that we can take. And as with the other ones, we're going to look at both options here. So finding the equation of a circle that contains 2 points and we have a center line as well. So we have a line on which we know the center lines. And what this actually means for us in terms of the geometric approach is it actually kind of saves us a little bit of work here. So let's have a little look at maybe how that is. So looking at my line here, for example, if I do my minus a over b, that's minus 1 over 5. So I'm looking at negative slope here. So I'm looking at a line that kind of goes, I suppose, something like this one, for example. So something like this one. I have my 2 points 0, 2. Okay, so I can just plot these points anywhere really. So we can put one of them maybe here, 0, 2, and maybe the other one might be 1, 5, could be really anywhere. We could maybe put it up here, for example, 1, 5. Okay, so if I look at this idea, if I was to connect those 2 points up to make a common chord, like we've been doing, I suppose, with all the other cases, I know that if I find the perpendicular of that chord, the perpendicular bisector of that chord, that will pass through the center. What helps me here is I already know the equation of another line which definitely passes through the center, and that's my line here, x plus 5y equals 15. I know that that line has to pass through the center without me having to do any work at all. So if we can find the equation of that perpendicular bisector, then we can kind of make use of that. So let's kind of have a look. So if I find the equation, let's give that a name, so we'll call it j. I'm just going to find the slope, first of all, of y2 minus y1 is 5 minus 2, 1 minus 0 is 3 over 1, which means the perpendicular slope, which is the slope of j, will be minus a third. Okay, let's just mark that in there. So I found my slope of my perpendicular bisector. I need to also find the midpoint, of course, as we've done with, I suppose, all the other cases. So 1 plus 0 over 2, 5 plus 2 over 2. So that's going to be a half, and 7 over 2. Okay, that's my midpoint here. Finding the equation of this line then, y minus 7 over 2 equals minus a third, x minus a half. Okay, let's try and, I suppose, work this one out, simplify all of that, 1 over 6, let's multiply by 6 there, so 6y minus 21 minus 2x plus 1. I'm bringing everything to one side, 2x plus 6y equals 22. Okay, so I have my one equation here coming from my perpendicular bisector of my chord. That's my equation of line j. And I already know from the question that the line x plus 5y equals 15 contains the center. So since I know that perpendicular bisector j has to go through the center, and I know that my other line also has to contain the center, then that must be the point where those two lines are going to meet, because we know any two lines will only meet at one point, and since they both have to go through that point, that has to be the point of intersection then. So we can kind of make use of that then in our simultaneous equation. So I'm just going to continue it underneath here. 22 minus 2x minus 10y equals minus 30, and that gives me minus 4y equals minus 8, and y equals 2. Subbing that back in then, x plus 5 times 2 equals 15, x plus 10 equals 15, so x equals 5. So I'm ending up then with that xy, of course, representing my center, so that's my center 5, 2. Okay, the last thing I need to do then really is just find the radius. The radius then is the distance from any of these points, so we could pick either of the 2 points. So say q to the center is going to give me my radius. So that's going to be, if I look at point q as 0, 2, so 0 minus 5 squared plus 2 minus 2 squared, which is going to be minus 5 squared plus 0 squared, and that is going to overall give me root 25, which is 5. So the equation of that circle then is x minus 5 squared plus y minus 2 squared equals 5 squared, or of course 25 there. And as we know or should I suppose at this stage know, if I was to multiply or expand out that equation or that format of my circle, I would end up with the longer format. Looking at the second option then, I suppose, which is the more algebraic way that we could do this, so not using that geometric sense to the full same sense, we end up, I suppose, using a lot of the same ideas. But these 2 points I know are on the circle, so let's sub them in. So I'm subbing in the point 0, 2. So subbing that in, 0 squared plus 2 squared plus 2g0 plus 2f2 plus c equals 0. I always like questions like this where one of my coordinates is 0, because it allows me to immediately get an equation then that only has 2 variables, and that could be quite helpful for us. Subbing in the point 1, 5 then as well, so 1 squared plus 5 squared plus 2g1 plus 2f5 plus c equals 0. That's 1 plus 25 plus 2g, sorry, don't know why that's, my ink to shape is on, 2g plus 10f plus c equals 0. So 2g plus 10f plus c equals minus 26. We have 2 equations now that I've come up with, one of them only in 1 variable, another in 2 variables. So let's just kind of, I suppose we'll bank those for a second. I want to now make use of the other piece of information I have, which is that the center is on the line x plus 5y equals 15. Now when I'm working in this algebraic sense, and when I'm using my g and f and c and all of those, we need to remember that that means my center I'm calling minus g minus f. Okay, since I'm using that bigger format of the circle, that is the kind of format that my center is given in. And if the center is on that line, then that means that I can sub it into that equation of the line, and it should satisfy the equation. So minus g minus 5f, let's clear that there, minus g minus 5f equals, sorry, rubbed it out, equals 15. Okay, and that is kind of my last equation that I have here. Okay, that's my last piece of information. So we have a number of ways of looking at this, because I kind of have 3 different equations that I can make use of here. So one way that we could look at this is we have one longer equation here, which is my green equation. And I have 2 other equations then with varying letters. One has g and f, one has f and c. So if I'm looking at that case, what I might choose to do is, for the blue equation here, I could rewrite this as minus 4 minus 4f. For my pink equation, I could rewrite this as g equals minus 5f minus 15. And in that way now I've rewritten both equations to kind of fill in to this green equation in place of each of those letters. So I have 2 minus 5f minus 15. So we're kind of solving by substitution as opposed to elimination here, which would be our normal simultaneous equation, plus minus 4 minus 4f. Now if we didn't want to go this way, we maybe would still rearrange that blue equation and sub it into the green one to eliminate c, and then we could do a simultaneous equation. But we might as well just go the full length here really. So that's minus 10f minus 30 plus 10f minus 4f equals minus 26. Okay, so let's see where this is going to leave me overall. Minus 34 minus 4f equals minus 26. Minus 4f equals, well, that's going to be 34 minus 26 plus 34, which is 8, which means f is equal to minus 2. Okay, using that now with those 2 equations I had, g is minus 5f minus 15, so that's minus 5 by minus 2 minus 15, which is 10 minus 15 or minus 5, and I had c equals minus 4 minus 4f, minus 4 minus 4 by minus 2, which is minus 4 plus 8, which is 4 overall. Okay, so getting my equation of the circle then, x squared plus y squared plus 2, sorry, g is my minus 5 there, x plus 2 f y plus c, and we simply simplify then that equation down. Okay, until we get our overall answer there. Okay, so same idea applies in both cases. In that case, the algebraic way maybe would just appeal to people more. The geometric one, then I suppose we saw that the line going through saves us that little bit of extra work. But there is always that sense, I think, with the geometric ones that we then have to go and find the radius. Whereas at least with the algebraic, we don't need to find the radius. We find g, f, and c, and we sub them into our equation of the circle. So the last little type I want to look at here, or the last little just kind of extra bit of the question, is finding the radius of a circle given the length of the chord of the circle. So this circle has centre 2, 3, and it makes a chord of length 4√3 with the y-axis. Find the equation of the circle. So as with all our questions here, let's kind of start with some sort of sketch so we can see what we're looking at. So we have a circle that has a centre here of 2, 3. It has a radius unknown. Okay, we're not actually told the radius here. That's actually, we're asked to find the equation. So I suppose because we know the center, the kind of, I suppose, unsaid thing there is find the radius. And we have this chord. Okay, now I'm going to make use of a few different things here, and again it's coming back to really this geometric, so that's kind of why even though we're saying yes, the algebraic can work a lot of the time, and we showed with all of these questions that they can generally be done both ways, you do still need to know these theorems, and they'll come up again in geometry as well, so they are worth kind of putting the effort into now. But what I'm kind of using here is that the center and that line from the center to the chord will bisect the chord. So since I know this chord has an overall length of 4√3, I can use that to my advantage here and say that because it's going to be bisected, this part here is going to have a length of 2√3, as is this part here. So these two parts of my chord between my circle points here, between those points of intersection with the circle, will both have a value of 2√3. Okay, I also have then my radius. Okay, my radius, I suppose, is the one that I'm looking for. I'm kind of looking at this now as a triangle. So I suppose that's what I'm saying. I also have it here. So I have my radius here. I have my 2√3 here. The only thing I would need to find radius would be this distance down here. Okay, and we can call that x. And the reason I'm kind of calling that x is that distance is going to do with how far I've traveled along the x-axis. If we look at the question here, it says that this makes a chord with the y-axis. So this line that I've drawn in here is actually the line x equals 0, which is the y-axis. So since we've gone from x equals 0 to x equals 2, where my center line is, so we can kind of see here my center is on that line x equals 2, that's going to mean that this distance must be a distance of 2, a horizontal distance of 2 that I've traveled to get to that center. So x here is actually going to be 2. And once I've identified that, then it's just a case of doing Pythagoras' theorem. Okay, and again, this is the sort of thing that mightn't necessarily come up as its own sort of question, but it could come up as part of another question. So it is very important to be aware of all of these different kind of ways that you can be asked these questions. Now, we don't have to consider plus or minus 4, of course, because radius has to be positive. So radius is 4, and equation of the circle then is x minus 2 squared plus y minus 3 squared equals 16. Okay, so that's kind of our last little type, I suppose, of the questions for the equation of the circle. And again, all of these different types really are just bringing together different aspects that we've used across these questions. So I suppose the next thing then is to do the exam questions, and we'll go through those, I suppose, in a separate video just to keep each of these short.